You can. The trick there is your first quadrant's really small, and all this graph is a first quadrant graph. So if you do use one of these papers, maybe just, yeah. So draw this as your y-axis, and draw this as your x-axis like this. Because that's, I mean, then you have plenty of room to do what you need to do. Okay. So f of sy would be strawberry is 35 for a strawberry plus 25 for a yellow cake. Okay. So is that okay where that came from? Okay, so that's the f of sy. That's not going to be part of the inequalities. Now we have decorating assembly time for yellow cake is 2 hours. So it takes 2 hours to make a yellow cake. 3 hours for a strawberry cake. And how many total hours do we have? 450. So that's one option that I'm hearing. X plus y or S plus y is less than or equal to 450. Now what does S represent? Does it represent a time or does it represent a quantity? Okay, so these variables represent quantities. So in order for it to represent a time, you have to take it times a time. So it's not going to be S plus y or X plus y. But if a strawberry cake takes 3 hours, it's going to be S times 3. So it's going to be 3S plus 2y has to be less than or equal to 450. So it's 3 hours for a strawberry cake, 2 hours for a yellow cake, and we have less than 450 hours. So you can use your labels to help you figure that out. Hours, hours, hours. Now, do we have any other numbers in this problem?
Yeah.
No. So the other two are kind of other two inequalities because we need a bounded region. You can't get a bounded region with just one line. So what's the minimum number of strawberry cakes you can make? Minimum. 0. Can you have negative strawberry cakes? Can you have negative yellow cakes? No. So the other inequalities here are S has to be greater than or equal to 0. Y has to be greater than or equal to 0. So we're ready to graph. Now when I start looking at my grid, these two down here, the zeros, those are pretty easy, but I have a big number, 450, don't I? So let's think about what our intercepts would be. If I don't make any yellow cakes, if all I do are strawberry cakes, how many could I make in 450 hours? 15? 3 times 15 is 450. Take 450 divided by 3, you get
150.
So I could 150 strawberry and 0 yellow. Or what about if I make 0 strawberry? How many yellow could I make? So we take 450 divided by 2, you get 225 yellow. So one axis, I'm going to have S be kind of like my X. So one axis I have to go to 150, the other one I have to go to 225. Count by 25s? Sounds good to me. I like it. Now yours may be a little bit different if you did different variables, you put them on different axes. So if you're thinking through this problem in your head, you're like, okay, is it better, based off these intercepts, is it better to produce all strawberry cakes or better to produce all yellow cakes? Strawberry cakes take longer, but you get more money for them. Yellow cakes take less time, and you get less money for them. So you notice if you make just strawberry cakes, you can make 150 of them. If you make just yellow cakes, you can make 225 of them. So this is where this formula now comes into play. This 35s plus 25y, you use our vertices. Now keep in mind we are using the axes, so is 0, 0 a vertex? Technically yes, but is it going to produce any revenue to produce 0 cakes? No. So it is a vertex of the system, but really you're checking these two vertices out right here. You getting the same numbers I did? No? What did you get, Dawson D? 3,750. Which one? The 115.0? I think you switched your variables. Yeah. So 150 is my strawberry cake, so it has to go in the S, the strawberry cake one. And then you took the strawberry cake times the cost for lemon. I think you just split those two. So, yeah, I mean, 0, 0, if you put that in there, that's going to be 0, right? Okay. So, what did they want here, though? Did they want a minimum or a maximum? They wanted to maximize their revenue. So, which creates the most money for them? And that would be producing 0 strawberry and 225 yellow cakes. So even though yellow tape are less expensive for the consumer to buy, you can make a lot more of them. And then you can sell more of them and you can make more money than selling the more expensive ones. So it's not always the most expensive things that make you the most money. Okay, you think of like luxury cars. How many people actually buy high dollar, high end luxury cars? Okay, on normal, average people. Okay, not very many. So if you're trying to have a luxury car store in Gossel, you may not sell a lot of them. Now let's get the Chevys and the Fords out there. Now you're going to start selling them. Okay, they're not as expensive, but it's the ones that people will buy. Economics. Okay, so they want to know how many of each type of cake should be made to maximize revenue. So this is Jenny's Bakery. So Jenny should make 225 yellow cakes and 0 strawberry cakes. For a revenue of $5,625. Good day's work. Well, it depends how many laborers you have. If you have 15 workers, that's only 10 hours each for each of them. No, it's more than that. 30 hours. 30 workers, it's only a 15-hour day for each of them. A little bit of overtime. But then you have to pay everyone out of that $5,625 too. Yeah. Okay, feeling a little bit better with the process? Let's try one more together, and then I'll have you try 25 on your own, see how that goes. I do think a lot of times if you can get the inequalities, I think we can handle the rest of it okay. So 24, I want you to, a little bit more information in this one. See if you can come up with the inequalities and the function.
One of those meetings.